In February 2002, the fastest gaming card most reviewers could buy carried an NVIDIA logo, and the gap was not subtle. GeForce4 Ti 4600 arrived at a time when NVIDIA had turned a succession of GeForce generations into something close to an expectation of leadership. In some high-resolution tests, it could pull dramatically ahead of ATI's Radeon 8500, a card that had arrived with impressive programmable features but never fully displaced NVIDIA at the top. For ATI, this was more than another lost benchmark. The company had spent years proving that it could build capable graphics hardware, especially for OEM systems and notebooks, yet among enthusiasts, the pattern was stubborn. ATI would introduce an interesting Radeon, NVIDIA would answer, and the performance crown would move back toward GeForce. If ATI simply narrowed the immediate gap, it would still be competing against hardware NVIDIA had already shipped. The company needed a product that could change what the next high-end card was expected to be. That pressure had been building since the original Radeon appeared in 2000. ATI was not a newcomer to graphics. It had been shipping display hardware for years and possessed deep relationships with PC manufacturers. But the enthusiast 3D market that emerged in the late 1990s rewarded different strengths. NVIDIA had moved rapidly from Rive AT&T to GeForce 256, GeForce 2, and GeForce 3, each generation increasing the amount of graphics work handled directly by the processor. GeForce 3 was especially important because it brought programmable vertex and pixel shading into consumer hardware under DirectX 8. Future games would rely less on fixed combinations of texture and lighting operations, and more on small programs running inside the graphics pipeline. ATI's Radeon 8500 supported advanced shader capabilities of its own and could compete impressively in some conditions, but launch drivers and uneven game compatibility weakened the impact. By early 2002, GeForce4 Ti refined NVIDIA's existing formula with higher throughput, stronger memory efficiency, and mature software. It did not represent an entirely new API generation, yet it was fast enough to make ATI's immediate problem severe. R300 emerged from a strategy aimed at technology leadership rather than another incremental answer. The design would have to do several things at once. It needed to outperform GeForce 4 in the games people were playing in 2002, support the more flexible graphics model being prepared for DirectX 9, and avoid repeating the software reputation that had limited enthusiasm for earlier ATI launches. It also had to be manufacturable at a price buyers could accept. None of those goals guaranteed the others. DirectX 9 was not yet the foundation of current games. Most titles being benchmarked while R300 was being completed still relied on DirectX 7, DirectX 8, or OpenGL-era workloads. Building heavily for future shader precision and flexibility could consume transistor budget without producing immediate frame rate gains. Optimizing only for current games, however, risked leaving ATI with a fast card that became architecturally old almost as soon as Microsoft's next API arrived. NVIDIA faced the same long-term transition, but it had the advantage of leading the market while its next architecture was still under development. ATI had to make a forward-looking design win the present as well. That requirement shaped the scale of R300. The new processor would carry far more parallel pixel processing capacity, more vertex processing hardware, a much wider route to memory, and a shader design intended for the precision rules of DirectX 9. Such choices created obvious risks. A wide memory interface made boards more complex. More pipelines demanded enough memory bandwidth to keep them useful. A chip approaching 100 million transistors on the same broad manufacturing generation used by its predecessor would be physically ambitious, expensive, and difficult to cool. The architecture could look extraordinary in a diagram and still fail if it could not reach useful clock speeds, or if drivers could not translate the hardware into reliable performance. ATI accepted those risks before it knew exactly how NVIDIA's response would look. R300 was not designed after GeForce FX appeared. It was an attempt to stop responding to finished NVIDIA products altogether. By the middle of 2002, the first public evidence of that shift began to appear. ATI was preparing a card that would not ask reviewers to forgive weaker performance in exchange for features that might matter later. It was supposed to arrive with both. The company that had spent years chasing GeForce was about to find out whether it had built an architecture large enough to reverse the direction of the chase. When ATI revealed the Radeon 9700 in July 2002, the easiest way to understand the design was to look at how aggressively it attacked the bottlenecks of the previous generation. R300 contained 8 pixel pipelines, twice the count of NVIDIA's GeForce4 Ti flagship, along with 4 vertex shader units. Feeding that much rendering hardware required a memory system far wider than the 128-bit interfaces common on high-end consumer cards. ATI connected 128 megabytes of DDR memory through a 256-bit bus, and divided the controller into multiple channels so that the width could be used efficiently rather than treated as one giant block. Hyper-Z, ATI's collection of techniques for avoiding unnecessary memory traffic, was refined again because raw bandwidth alone would not be enough if the chip wasted it drawing pixels that would never be visible. The resulting processor was enormous by the standards of a consumer graphics card in 2002, roughly 100 million transistors on a 0, 15-micron process. ATI used flip chip packaging, while the production Radeon 9700 Pro operated at a 300 to 25 MHz core clock. The card paired that core with DDR memory operating at an effective 620 MHz, producing nearly 20 gigabytes per second of theoretical memory bandwidth. Those figures only mattered if the architecture could turn them into visible advantages. R300 had been built so that expensive image quality features would no longer reduce performance as brutally as they had on earlier hardware. Full-scene anti-aliasing was one of the clearest examples. Jagged polygon edges were an obvious artifact of rendering a three-dimensional scene onto a finite grid of pixels, but smoothing them had historically required enough additional sampling work that many players disabled the feature to preserve frame rate. Anisotropic filtering addressed a different problem, improving the clarity of textures viewed at steep angles, yet it too could consume significant performance. ATI redesigned its approach to both. Radeon 9700 Pro used multisample anti-aliasing with gamma-corrected resolve and could apply higher levels of filtering while preserving far more of its speed than the GeForce 4 generation. This meant the chip's advantage would not necessarily look most dramatic in a benchmark run at ordinary quality settings. It could grow when the reviewer enabled the visual features buyers purchased an expensive card to use. DirectX 9 pushed the design further. The new shader model required greater precision and more flexible programs than the DirectX 8 hardware already on the market. Radeon 9700 Pro was designed to implement that model in hardware, including floating-point pixel processing and longer shader programs. At launch, this was partly a promise. DirectX 9 itself had not yet become the basis of shipping games, and buying a graphics card because of an API developers were still preparing carried obvious uncertainty. ATI avoided the trap of making R300 useful only in future software. The same resources that supported the new shader model also gave the card enormous throughput in existing DirectX 8 and OpenGL workloads. There was another signal that the architecture was arriving at the right moment. ID Software was developing Doom 3, a game whose dynamic lighting and programmable rendering paths were widely expected to push graphics hardware beyond the engine's dominating current benchmarks. The project became a public reference point for the coming generation. ATI could demonstrate that R300 belonged in that conversation before DirectX 9 games were common because the card's shader capabilities aligned with the workloads developers were beginning to explore. That did not prove the 9700 Pro would dominate every future engine, but it gave ATI something it had rarely possessed against NVIDIA: credibility in the next generation before the competition had shipped its answer. In August 2002, ATI began shipping Radeon 9700 Pro boards to resellers at a suggested price of $399, the same territory occupied by flagship graphics cards rather than a value challenger. The price itself was a statement. ATI was not asking buyers to choose Radeon because it was cheaper than the fastest GeForce. It was asking them to pay flagship money because it believed the flagship comparison favored ATI. That confidence still had to survive the weaknesses that had damaged earlier Radeon launches. Reviewers would test drivers across games written for several APIs, examine visual artifacts, compare filtering methods, and place the card into systems where the CPU might hide part of its advantage. NVIDIA's GeForce 4 Ti 4600 was a mature, known quantity with strong software support. A new architecture could lose credibility through crashes or rendering errors, even if its theoretical design was superior. For perhaps the first time in ATI's recent enthusiast history, however, the issue was no longer whether its new card could get close enough to NVIDIA to remain relevant. Reviewers were about to find out what happened when they enabled the settings that had previously made expensive hardware slow down. The answer became visible as the August reviews appeared. At conventional settings and lower resolutions, Radeon 9700 Pro did not always produce the kind of overwhelming lead its architecture suggested. Graphics processors can only render work the rest of the system supplies, and the fastest cards of 2002 were already capable of running some existing games quickly enough that the CPU became part of the limit. In those cases, GeForce 4 Ti 4600 could remain close, and a benchmark chart could make the new Radeon look merely faster rather than transformational. Increase resolution, add anti-aliasing, enable anisotropic filtering, or combine those demands, and the relationship changed. The GeForce 4 Ti 4600 had been designed as an exceptionally strong DirectX 8 era product, but quality features consumed a large share of its available rendering and memory resources. Radeon 9700 Pro had considerably more pixel throughput and almost twice the memory bandwidth, supported by an architecture designed to avoid unnecessary traffic. In contemporary testing, ATI's advantage often widened sharply as the workload became more demanding. The card could render at high resolution with anti-aliasing and texture filtering while maintaining frame rates that made those options practical rather than decorative checkboxes. A buyer spending hundreds of dollars on a premium monitor and graphics board no longer had to choose as often between a clean image and smooth motion. Benchmark leadership can mean several different things. A card that produces the highest frame rate with every quality option disabled is not necessarily the card that provides the best experience once those options are used. Radeon 9700 Pro changed the high-end conversation by making visual quality part of the performance comparison. Its multi-sample anti-aliasing could operate at 2x, 4x, and 6x levels, and its anisotropic filtering implementation imposed relatively modest performance costs in many contemporary tests. The exact advantage varied by game, driver, and setting, and the methods used by ATI and NVIDIA did not always produce identical images. There was no honest single percentage by which R300 was faster. What reviewers could see was that the gap often grew under the conditions enthusiasts actually hoped a $399 card would handle. The memory interface was crucial. 8 pixel pipelines could have become an expensive collection of idle hardware if data could not reach them quickly enough. The 256-bit DDR bus and ATI's memory controller design gave R300 the bandwidth to sustain high-resolution rendering, while Hyper-Z reduced traffic associated with hidden pixels. That combination was especially useful when multi-sampling increased the amount of color and depth information moving through memory. The architectural pieces had been designed together rather than as isolated headline specifications. R300's DirectX 9 support remained harder to judge because launch day games could not yet show its full purpose. This is where hindsight can distort the story. It is easy to look backward from later shader-heavy titles and assume buyers in August 2002 knew exactly how valuable full DirectX 9 compatibility would become. They did not. APIs evolve, developers choose different rendering paths, and first-generation implementations sometimes age badly. What buyers could evaluate immediately was that ATI's future-oriented hardware was not demanding a sacrifice in current games. The card was already the fastest solution in many existing workloads, and its advantage often expanded at demanding settings. DirectX 9 compatibility therefore looked less like a speculative feature purchased instead of performance and more like additional headroom attached to a card that was useful now. The software story was also different from the one that had accompanied Radeon 8500. ATI's drivers were not magically perfect, and compatibility problems did not disappear from PC gaming, but launch reviews were not dominated by catastrophic software failure. The company had spent effort improving the Radeon driver organization, and R300 arrived able to demonstrate its architecture across a broad enough range of tests that reviewers could focus on. Performance and image quality rather than treating the card as unfinished hardware waiting for future software to rescue it. NVIDIA's reputation had been built partly on execution, not merely designing fast chips, but supporting them consistently. ATI could not seize the enthusiast crown if every architectural victory required an apology for drivers. The change became visible beyond retail reviews. ATI later reported that Radeon 9700 Pro was selected for flagship systems from major PC manufacturers, evidence that the architecture was not confined to enthusiasts assembling their own machines. High-end OEM design wins required supply, qualification, drivers, and planning on schedules that extended beyond one benchmark article. R300 was turning into a platform rather than a demonstration. By the end of the summer, NVIDIA remained an enormously powerful graphics company with the GeForce brand, deep developer relationships, mature drivers, and another architecture under development. Nothing about Radeon 9700 Pro guaranteed that ATI would retain leadership once NV30 arrived. The situation had nevertheless reversed in one important respect. NVIDIA's next chip would not enter a market waiting for the leader to extend its advantage. It would enter a market in which ATI already held the strongest current product and the first consumer implementation of the graphics model. Both companies expected to define the next generation. For once, the burden of answering had moved to NVIDIA. That reversal grew more consequential with each month. NVIDIA's answer remained absent. Graphics leadership in the early 2000s was unusually sensitive to timing. A flagship did not need to remain fastest for years to influence buying decisions, developer priorities, and expectations. It needed enough uncontested time for reviewers to establish it as the reference point. Radeon 9700 Pro received that time. NVIDIA announced the architecture that would become GeForce FX later in 2002, but finished GeForce FX 5800 products did not immediately replace GeForce4 Ti on store shelves. ATI therefore spent the final months of the year competing primarily against hardware from the previous API generation. The delay amplified every strength R300 already possessed. DirectX 9 reached its final release later in 2002, turning what had been a forward-looking compatibility claim into support for a released Microsoft API. Developers still needed time to ship games that depended heavily on its shader model, but ATI could now point to hardware already in users' PCs that implemented the specification. Radeon 9700 Pro had not waited for the software ecosystem to catch up before becoming useful. The software ecosystem was beginning to catch up with a card that had already established itself. ATI also expanded R300 downward. Radeon 9500 and 9500 Pro products brought parts of the architecture into lower price segments, while the non-Pro Radeon 9700 offered a less expensive version of the high-end design. Expanding R300 beyond the flagship increased the amount of compatible hardware developers could realistically target. NVIDIA had understood this principle for years through the breadth of the GeForce family. ATI was now applying it with an architecture that had begun at the top rather than filtering upward from the middle. The Radeon 9500 Pro was particularly revealing. It retained much of R300's programmable feature set, an 8-pipeline structure, while using a narrower memory interface and lower clocks, showing that ATI intended DirectX 9 capability to spread beyond the $399 flagship. That made the architecture more than a Halo product. A developer experimenting with the new shader model could increasingly expect compatible Radeon hardware to exist at several price points, even though performance within that family varied substantially. Competition still extended beyond DirectX feature checklists. OpenGL performance remained important, particularly for games based on engines from ID software, and driver behavior could shift results over time. Programmable graphics was also making architectural comparison more dependent on workload and code path than the fixed function era had been. Different chips could expose similar features, yet reach very different performance depending on precision, compiler behavior, rendering method, and the way a game used its shaders. That complexity did not weaken ATI's lead. It made the lead more impressive because R300 was competitive across both existing workloads and the new programming model. During the GeForce 2 and GeForce 3 years, NVIDIA could often define leadership through a combination of raw speed, new features, and rapid product cadence. R300 disrupted all three at once. ATI had delivered substantially more throughput than its own previous flagship, full hardware support for the coming DirectX generation, and a shipping product before NVIDIA's equivalent architecture. The response could no longer be a small clock speed increase. NVIDIA needed a design capable of competing in programmable shader workloads, image quality features, memory performance, and the marketing battle around DirectX 9. ATI's business position benefited from the technical success. In its 2002 reporting, the company described Radeon 9700 Pro as having captured the performance lead and highlighted design wins with major OEMs including Dell, HP, Gateway, Apple, Fujitsu, and NEC. Corporate language naturally presents products in the most favorable light, but the broader evidence supports the underlying shift. ATI was no longer strong mainly in notebooks and OEM graphics, while NVIDIA owned enthusiast prestige. The same architecture was now helping ATI compete for both. There were limits to what this victory meant. Radeon 9700 Pro remained expensive. Many gamers continued using GeForce4, Radeon 8500, or cheaper hardware because contemporary games did not require a 9700 Pro to remain enjoyable. NVIDIA still possessed a large installed base and relationships with developers. New drivers could alter performance. The first DirectX 9 games would arrive gradually rather than immediately validating every architectural choice ATI had made. A performance crown is not a market monopoly. ATI had nevertheless reversed the competitive psychology of the market. For years, Radeon products were judged against the latest GeForce. R300 made NVIDIA's roadmap the one being judged against ATI. Every month, NV30 remained unavailable, allowed the 9700 Pro to become the comparison point for the coming generation. Could NVIDIA match its anti-aliasing efficiency? Could it exceed its shader performance? Would higher clock speeds demand uncomfortable power or cooling compromises? Could the card arrive before ATI refined R300 again? Those were questions created by ATI's product. That distinction separates this story from the later GeForce FX story. The key event here is not the eventual problems of NV30. It is that ATI had already built enough of an advantage that any weakness in NVIDIA's response would be magnified. Radeon 9700 Pro changed the penalty for being late. NVIDIA was no longer delaying a faster successor to a product that already led the market. It was delaying the hardware needed to regain ground from a rival that had reached the next generation first. When GeForce FX 5800 finally entered independent testing in early 2003, the market it encountered had already been shaped by Radeon 9700 Pro for roughly half a year. NVIDIA's new architecture brought its own ambitious ideas, very high clock speeds, and full support for programmable graphics, but it did not erase R300's position simply by arriving. The detailed reasons belong to the GeForce FX story itself. Here, the important point is that ATI's 2002 gamble had survived long enough to become more than a temporary benchmark surprise. NVIDIA was being forced to fight for a crown that had already moved. ATI did not stop with the original R300. Radeon 9800 Pro followed in 2003 with an evolution of the architecture, improving clock speeds and refining parts of the design rather than discarding the foundation. The continuity showed how much R300 had gotten right. Successful architectures are rarely perfect, but they create room for refinement. ATI could use the same basic philosophy to cover several products and price levels while concentrating engineering effort on drivers, yields, clocks, and targeted improvements. The company had escaped the cycle in which each new Radeon merely tried to catch the latest G-force. The shift was especially visible in how image quality was discussed. Anti-aliasing and anisotropic filtering had existed before Radeon 9700 Pro, but the performance cost often encouraged reviewers to treat them as optional tests rather than normal settings. R300's combination of bandwidth, multi-sampling, and filtering efficiency made it practical to ask a more demanding question. Not simply how fast a card could draw a game, but how fast it could draw that game with the visual features people actually wanted from expensive hardware. Once reviewers and buyers became accustomed to that standard, a competitor could not easily retreat to lower quality settings and claim leadership through a larger frame rate number. The benchmark itself had changed. DirectX 9 produced a similar transition over a longer period. Radeon 9700 Pro did not transform the software landscape on the day it shipped. Most games did not suddenly require its shader model. ATI's advantage was having hardware in the market before those workloads became common, while still delivering exceptional performance in the games people were already playing. As shader-intensive titles arrived, R300 owners were not relying solely on a feature printed on a box. They possessed an architecture designed around the precision and programmability the API expected. None of this means ATI suddenly became infallible, or NVIDIA suddenly lost its engineering ability. Graphics competition remained cyclical. Both companies would win and lose later generations, and future products would expose weaknesses in architectures that once appeared dominant. Radeon 9700 Pro is historically interesting because it interrupted an existing pattern at exactly the point where the rules were changing. NVIDIA had built enormous momentum through the first GeForce generations. ATI disrupted that momentum by bringing a much wider, more parallel architecture built for both the workloads of 2002 and the programmable graphics model that was about to follow. The achievement is easiest to see by returning to the beginning of that year. GeForce4 Ti 4600 arrived as a polished extension of NVIDIA's leadership, and Radeon 8500 could look badly outclassed in demanding tests. 6 months later, reviewers were discussing ATI as the technology and performance leader. The result changed more than one product ranking. It demonstrated that the enthusiast graphics market was still open to architectural disruption. Brand momentum, driver reputation, and developer relationships were powerful advantages. But they could be challenged when a competitor arrived with enough performance, improved software, and enough future-facing capability at the same time. For ATI, R300 validated a strategy aimed at technology leadership rather than remaining primarily an OEM supplier with occasional high-end products. For NVIDIA, it meant the next generation could no longer be approached as another extension of an uncontested lead. Radeon 9700 Pro therefore deserves a more precise description than the card that beat NVIDIA. It defeated the GeForce for generation in a specific historical window, often by large margins under demanding settings, and it reached the DirectX 9 era before NVIDIA had a shipping equivalent. NVIDIA would respond, and the rivalry would continue for years. R300's lasting importance is that it changed which company was setting the target. ATI entered 2002, chasing a competitor whose flagship could double Radeon 8500 in some tests. It left the year with a product every competing high-end architecture had to explain itself against. That was the real breakthrough. Not a permanent victory, but the moment ATI proved it could arrive first, define the high end, and force the most powerful graphics company of the era to answer.